Hello, everyone. My name is Kristina Hammond. I'm a Senior Bat Biologist with Western Ecosystems Technology, or WEST. Today, I'll be presenting on the strategies for large acoustic deployments. So some of the challenges to large acoustic projects can vary from your detector selection for any given project, management of large amounts of equipment, consistency of the deployments and data management, and accounting for enough skilled field biologists for your acoustic deployments. So a little background about WEST and our strategies. In 2024, WEST had over 70 acoustic projects, deployed over 1,000 acoustic detectors across North America, and covered multiple survey types, including long-term bat activity surveys, NABat surveys, U.S. Fish and Wildlife Service presence-absence surveys, optimized smart curtailment projects, and general research projects with tailored objectives to individual projects. So some of the strategy WEST implements to cover all these projects is having project-specific bat experts assigned to each project, even when a bat biologist is not deploying the detectors, but being available to answer any questions of the field biologist and reviewing all data to detect any detector issues or deployment issues. Management of all the detectors through a centralized location, having field manuals and help documents for each survey type, and custom programs for our detectors that enable quicker detection of any issues, and then quality checks at all stages of data collection. So some pre-deployment considerations include selecting the detector type you choose to use based on your needs for versatility in the use of that detector versus ease of use by the field biologist. The consistency needed in the programming of each deployment based on the survey type, the longevity needed by the detector for potential long deployments where you might have needs for external power or need to swap out the microphones or acoustic cables or the detector itself. What is the weight and hardiness of the detector you have selected versus the need for portability? What are the number of microphones you need deployed at each individual acoustic site? And what needs do you have for flexibility of your placement? Do you need to put the microphone at various heights or attach an acoustic cable? Other considerations is the programming of your individual detector. Do you need customization by each acoustic site, or do you want uniformity across all your projects? What are the chances that your detector might get moved, where if you had set the prefix to a site name or entered lat longs that determine your sunset and sunrise times, that could have an influence? What are the skill sets of the user in the field and their capability of changing programming if needed? For your long-term acoustic projects, do you need to account for daylight savings in your recording time? What is your survey type? Is there any specific set programming requirements? How much data are you recording, and do you need to utilize a program to reduce the size of your data or power needs for a long-term project? At WEST, we like using a scheduled program that runs from 1800 to 0800, for example, on the majority of our projects. That way, if a detector gets moved between sites or projects, we still are covering the whole night and not losing any data that way, and we can make any time corrections we need to at a later date using an R program. It also enables for quick detection of potential issues during the summary file review. When programming your detector, do you want to use a computer configurator, which can be a great way to set one program and then import to a lot of detectors rapidly, and also have ease of use in identifying any potential issues in the program when you're setting it up on a computer? Versus do you have the need to program an individual detector based on the site location or lat long information to set the sunset and sunrise times? So equipment management at WEST, as I previously mentioned, primarily goes through a central storage location. Benefits to this is we have a limited number of individuals who go through every detector when it comes back from the field to make sure it is properly functioning and doesn't need any repairs before the next bat season. These folks become experts in the program and our setups and maintain consistency in our program across all detectors, make sure the date and times are set correctly, and all critical firmware updates occur before being deployed in the field or communicating those firmware updates needed to any detectors already deployed. Also, these individuals become great experts at troubleshooting any issues with the detectors and identifying potential user errors, equipment errors, or needs for any setup changes across our fleet, or changes in accessory items being used, or communicating with, say, Wildlife Acoustics to identify any potential firmware updates that may be needed, or microphone production errors. However, there are times that storing locally can be preferred as well. Say you want to safeguard a specialty program for a given project that's being deployed year after year, or the detectors were bought by a grant or a specific project and need to stay on location and make sure they're dedicated to that project and not going back into a general inventory. Then during project kickoff, things to consider for your project. How important is it to have a bat biologist being the one to deploy the detectors versus can a general field biologist do it with some good instructions? Do you need an in-person training or can you cover everything in a virtual kickoff? This can be determined by the type of acoustic project on, say, a U.S. Fish and Wildlife Service presence absence survey, where it is crucial the field biologist knows how to select the correct habitat, the correct detector placement, setup, have needs to change the detector settings, and also evaluate the data right after the recording in case the need of redeployment, versus is your project a long-term project with only a couple of detectors, so the detectors can be maintained by, say, an avian use biologist who just needs to maintenance the detector every couple of weeks and collect the data and ship it to a bat expert. Where in that case, a virtual kickoff might make more sense, where you introduce your bat biologist and introduce any help source materials for the field biologist that they should have on hand when they deploy the detector, and they know who to contact with any questions while they're at the detector doing the deployment. Other considerations are shipping a full acoustic kit to your field biologist versus having accessory items bought locally. And this can be important considering, say, your project is extremely remote and it is not near a large warehouse hardware store, or if the field biologist is inexperienced in acoustics, making sure they have all the items and aren't missing anything in the field that might be crucial to the deployment or troubleshooting at a later date. However, shipping full acoustic kits can be bulky and expensive. So buying locally sometimes can be beneficial if you want customization in your setup, avoid extra equipment the field biologists are carrying around and not using. However, that can also sometimes lead to issues in finding the equipment needed locally. And in that case, I highly recommend using the store's website or apps to look at their inventory beforehand, or even do a head order to pick up. That way you can avoid time spent going from store to store trying to find all the equipment needed. So during data collection, during the first deployment for West, oftentimes when we have non-bat biologists acting as our field biologist, we make sure we have a bat biologist on call during deployment so that the field biologist can call with any questions they might have or issues they encounter. We make sure our field biologists take tons of pictures and documentation of any issues they come across and the setup, so that way if we have any questions during the analysis, we can go back and reference them. We make sure all our field biologists have a manual with simple step-by-step process of the setup and steps to do on the detector itself. We make sure they evaluate the deployment location. Is there signs of flooding or livestock that may cause issues to the acoustic setup over time? And we try and have a short interval between our first check after the deployment, and then have the summary file or log file reviewed by a BAT expert rapidly so that any deployment issues can be detected. We also provide checklists to help a non-BAT field biologist determine if there's any issues in the setup, such as making sure the detector reads going to sleep until 1800 for the first recording. Other considerations in your data collection is your interval in between data checks, and this can be determined by the accessibility of your site. Is a helicopter needed or a long hike to access your acoustic detector, or is it a drive-up site? How publicly visible is your detector that could lead to potential vandalism? What is the history with the landowner and their likelihood to leave the setup alone? Is there potential issues with wildlife or livestock? Could there be any large weather events such as lightning, heat, or flooding that could impact your acoustic detector? And then what is your power source? Are you running off of internal batteries, an external power source, or even a solar setup? Having a manual for your field biologist to reference and run basic checks and troubleshooting can be important to avoid any issues in the data collection. So just some fun pictures of issues you can have during data collection. So data submission strategies, that can also be important for projects. Having timely review of your acoustic data by a BAT expert can be really important to detect any hidden issues, such as the microphone being EMP'd. Redundancy in your data can be really important, making sure the field biologists always have a copy of the data in case of partial uploads to cloud storage, lost packages in the mail, or hard drive corruption. And then also consider the technology literacy of your field biologists in deciding the data submission strategies you want to take. Data review. So all our data goes through an expert bat biologist review after each session to help detect any issues. And this is done through intense review of the summary file or log file to confirm the number of files that should be present, that the detector started at the correct times and ended at the correct times. If not, that could account for a potential change in the program. Maybe the field biologist accidentally hit a pre-built program in the detector. Does the dump file time match the data sheet as the time it was deployed? Using a schedule program can help quickly go through the summary file and account for the start and end times by looking for 1800 and 0800. Was there interruptions in the data collection due to power issues or loss in microphone connection? And then also detect when the clock battery might need to be changed out when the date resets itself. Reviewing the summary file and data can help identify potential deployment step issues that the field biologist had, and also make sure all the data is accounted for the right station and session of data, and that data was not put in the wrong folder or the wrong data sent. Data organization and tracking. We find it's extremely important to track all the project information in one location in an Excel. That gives the full history of the dates it was deployed, what were the objectives, what heights were the microphones deployed at, that you might need if you go back and look at the data a few years down the road. It can help explain what happened each session. When was the detector deployed and checked versus the recording time to help account for any missing gaps in data. Was it due to deployment issues, or is that data missing? Count for the amount of data you should have and what was valid versus invalid. Having consistency in your data organization can really help process a lot of projects at once and also pass it between BAT experts. Having quality checks before the analysis to make sure you have a true clean data set can be crucial before running through auto ID programs and starting your analysis. Account for all your data. Make sure no data is placed in the wrong station folder. and also account for any potential duplicate files that could be in the data set. So with that, I thank you all and will take any questions at this time.
Thank you very much, Kristina, for that wonderful start presentation. Unfortunately, Kristina can't be with us today. However, she has two colleagues who can, which is Juliet and Kevin, and she'll be able to answer questions on this project anyway. So, and I already have questions coming in, so I'm gonna just get straight onto that. So the first question to both of you, I suppose, do you use some kind of project management software to track your recorders, and what each project kind of needs?
I don't think that we do. Julia, do you have any?
Excel.
Yeah,
Lots of Excel
basically.
sheets. Yeah. We've
Yeah.
got Excel sheets that track all of the projects. And then each project has its own sheet, which we link to so that anyone, if we have a bat liaison or an expert who is out on vacation or has to, unexpectedly leave for a while, any of other liaisons can find that information and step in and help answer questions. So the master spreadsheet links to all the others, which has the project specific information. So yeah, really Excel is our main tool, and just making sure everything is filled out.
There's nothing wrong with using Excel. I mean, I use Excel as well, and I'm sure a lot of people here use Excel, but it was, yeah. But I'm sure other people use other data management tools, and if you do, put them in the chat, because it's good to hear what people do use. But yeah, nothing wrong with Excel. If it's simple and everyone needs to know how to use it, it's a good solution. So I've got one that's kind of a site specific, which is quite interesting. Hi, we're collecting sound recordings at 3 sites, each with a single SM4 recording continuously. So I'm assuming this is acoustic data. We have some specific application ideas, but there is so much to extract that we would be willing to share openly. Any suggestions on how to go about sharing raw continuous recordings and suitable data repositories? So in other words, who wants all this data that somebody's recording?
Yeah, I mean, that's probably the largest problem with acoustics is just how much data you have and how difficult it is to store, to archive, to share, to move around. I don't have any secrets to share on that. We just do our best, and a lot of times we're mailing things, we're using servers to archive. We transfer electronically when we can, but I know there are a lot of repositories out there, but I'm not that familiar with most of them. And I think even then, those are usually for a relatively small amount of data, not just a mass data for a whole project.
Yeah, I mean, I don't know, there was the Silent Cities project, which was undertaken during lockdown. They want specific recordings in a specific format. There are other repositories like Xenocanto, but again, that's more for specific sounds. So it's a great question. Maybe this is the start of you starting up for your own repository. That would be really good. We'd all like to give you lots of information. We have lots to share. Okay. Microphones that stick out from the recorder are vulnerable to breaking or being eaten by animals. We've probably all experienced this. Do you have any experience of how best to protect these mics, especially in like rainforest environments? There's a related question asked. Sorry, yeah, and that's about it really. So basically, microphones that sort of stick out. How do you how do you protect your microphones from being eaten? We saw images of bears there, so I assume they do get munched.
Yeah, if we have livestock or wildlife issues, we should just try to gate the entire setup to try to keep them at least a distance away from the actual poles that we're using to avoid the knockdown. The individual mics themselves, we usually are kind of attaching them flush with the poles that we're using, so the pole itself sticks out, but not necessarily the microphone, and it depends on the mic you're using. We're usually extending a mic on a cable and then attaching it flush with a pole, or using like an elbow, a 45-degree elbow or a 90-degree elbow to attach the mic to, so that PVC elbow will protect the mic to some extent. But we generally don't use any type of weatherproofing. And I mean, for long-term deployments, we're usually still checking the microphones regularly. We're not just leaving them for a month, for 3 months, or for 6 months. So if we have any issues, we'll address them with the regular checks.
And I assume that whoever you're sending out to do these regular checks have a backpack full of spares and things like that with them. That's a common thing. Everyone's got a toolkit that you're sort of taking out.
Yeah, and generally they're going to have to change batteries and data cards. So yeah, they'll have that, and they'll have backup cables and mics as well. Yeah, so that's kind of how we do things, I guess.
So I think the rule is to put things on cables rather than have them attached to the unit, because then you've got a lot more flexibility, I suppose.
Yeah, I mean, we did have one. We don't do a lot in tropical setting, maybe almost nothing, but we do have some we had a project in Dominican Republic where we were actually trying out the new SM minis, and they have a microphone that's built in, but you basically are just deploying the entire bat detector. You don't have a mic on a cable or anything like that. And so, we just put those up off the ground, and they generally work pretty well. And we got data from, most nights of the year. But anytime we're using the SM4, we're using a microphone on a cable and extending it well off the ground.
Yeah, no, good point. So your opinions here. What's your opinion on large scale projects, done by citizen science versus actual biologists in the field? And can you share your simple manuals for setup? So basically, I think, using regular human beings as opposed to biologists.
I don't have a ton of experience with citizen science projects, but I think it just depends on the people doing it, and depends on the the overall organization and how you get the knowledge out to the folks that are doing it. I don't think this is complicated for the most part. Don't have to have someone with 20 years of experience to set up a microphone and download the data and make sure that everything's working. Most of our recording is probably done by biologists that aren't bat biologists. So I think citizen science has a lot of potential, as long as it's being done correctly and monitored. So, that's really kind of the point of these detectors, is to make the recording easily accessible and to do it on a large scale. I think it would be why not try to do that?
Yeah, I agree. I always feel that in the winter, when I bring in all my bat detectors, because I'm in the grim north, they just sit in there not doing anything, and really I feel like they should be outside just doing something. So they're outside just doing something. So going back to Excel, actually, you mentioned you store your data on Excel, or you monitor your data on Excel. Do you find that there's a limit to the number of data that you can keep in one place before Excel starts to struggle? Have you hit the maximum number of lines in Excel, basically?
We have had some programs where Excel won't work for the actual data analysis, which is when we jump to R. Excel is mainly just where we keep the information, like when were the dates that it was deployed, what would, site, location, goals of the project, that sort of thing. So the basic overall information. The actual data analysis is done through other programs like Kaleidoscope and R.
Excellent.
Yeah, but we do have data files, like just with species ID of bat calls, and you might have hundreds of thousands of files. Sometimes you get up into the million number. So I don't know what the number is, but I think when you get into the hundreds of thousands, your Excel spreadsheet starts to break down. At the very least, it gets really slow, and then it stops working. So we don't run into that a lot, because usually we're dealing with tens of thousands of rows in our spreadsheets. But if you have a really big project with a lot of data, that could be an issue. And I think then you just kind of have to just split it up into pieces. And I don't know a better solution than that.
No,
Analyze by station rather than by the entire project, something like that.
Yep. The next question links onto that, and really, I suppose it's So it's how large are the projects you're doing? In other words, what's your largest project? You know, how many recorders are you throwing out on a site and on some of your big projects?
Yeah, I'll let Juliet answer a few with her experience, but with mine, like Dominican Republic, we were doing 60 detectors recording for a year, and we were checking those detectors monthly. That's a lot of data. We had a project in Hawaii where I think we had around 30 to 50 detectors going for a long period of time. So you're recording, you know, dozens of terabytes. I think the Dominican project was over 100 terabytes of data. Generally, we're like a summer presence absence project might have 5 to 50 or 60 sites and generate 5 terabytes of data to 10 terabytes of data, something like that. So that's kind of a good range of things.
Yep.
Go
Pretty
on,
similar,
Juliet.
similar experience. Yeah. I mean, some projects you only have 100, a handful. Some of them have multiple levels. So you might have a mic, 3 meters off the ground plus one on the top of a turbine. So that can also add up to a lot of data as well.
Yeah. In other words, you are in the right place for the big data webinar. Let's have a look. No, but how do you store the large data sets? This person has a server system. Is that how you're using it? Are you put it on the cloud? Are you having big stacks of hard drives? How are you actually storing it for each project?
Both.
Big stacks of hard drives, actually. And we have a server where we try to put an archive of everything. But we also, I mean, functionally, we're using hard drives as individual analysts and biologists to use the data, and then we're storing it on a server. We do full spectrum wave files. We try to keep the copies of those to a minimum and try to archive just a single copy of those, I think, generally, because that's really what takes up so much space. We also convert files a lot to zero cross for some of our analyses, and those are easy to transfer and label and move around for folks to see. So we kind of we try to keep at least one copy of the full spectrum data on a server and then a separate copy on hard drives, and then we may have multiple copies of the zero cross data set too. So we've got different ways to look at the data and store it.
Cool.
It's tough though. That's a really tough problem. It's something we have a lot of issues with, and on every front, like storing it, archiving it, and moving the data back and forth to people so they can actually analyze it.
Yeah, us bat people really annoy IT departments.
Yeah, we really do. Yeah.
Especially a lot of the field biologists are out in the field or, at hotels without the best internet. So, uploading data isn't often a good option for them. So ending up sticking it on hard drive and putting it in the mail.
Yeah. I mean, electronic transfer of WAV files, we do that, but it's probably a small percentage of our overall data. Most of it we're just moving hard drives from place to place.
We've got one last question. Well, we've got loads more questions, but you might have to go into the Q&A and go through them. But so this is, excuse my ignorance here. Are you using any version of West EcoVision for bats? What is the status of EcoVision? So I don't know what EcoVision is. So I should let you talk about that.
We are trying to develop a machine learning method for identifying bat calls. So using known calls and calls that we've identified to train an AI model to actually be able to identify those bat calls. So we've got a zero cross version that we've been using internally. I'm not sure if we have any plans to release that, but it helps us essentially sort files into Myotis group and other species groups, and then we have somebody look at those individual groupings. So that's kind of how we're using it right now. We're trying to develop it and improve its accuracy, and we're working on a full spectrum version of it right now. So we're often too busy to get those projects done really quickly. So it takes longer than we'd like, but we are working on it right now.
Excellent. Well, thanks both of you for answering all those questions, and thanks to Kristina for the presentation. It's amazing, and we look forward to hearing more from West of what you're doing and how you're doing things in the future. So thank you very much, and good luck with everything you're doing. And we'll move on. You're getting lots of
Thank you.
applause as well,
Thank
which is
you.
even